So one of the things that we need to understand, and one of the tools in our toolbox, I should say, is encryption. That's really our best defense for data in transit and also data at rest, okay, as far as interception is concerned. And the two things that we need to be aware of are block ciphers. Now, block ciphers is one. We'll talk about stream ciphers in just a moment. But block ciphers is a fixed length group of bits, okay, or blocks. Each block of plain text has an equivalent size of block of ciphertext. All right, so let me give you the example here. All right, so here we have the old Bob and Alice. Okay, they've been around for a long time. They're good friends. They've been around since since the dawn of IT, it seems like. Well, basically, Alice wants to send some information or send a message to Bob, and she's obviously an extremely smart girl because, as you can see from her message, she says, "Hey Bob, Pluralsight is the best training company I've ever used, and that Security Plus instructor is awesome." So I couldn't agree with her more, quite frankly. But anyway, so there's an encryption algorithm that she uses, and she will encrypt. The same key is going to be used for the encryption and the decryption. Okay, that's referred to as a symmetric encryption algorithm. All right, so she's going to type up this message. She will encrypt it. As you can see, it passes through that block cipher, and it passes through in 64, basically 64-bit chunks typically. For every 64K that goes through, 64K comes out of in ciphertext. All right, so you have plain text, goes through the encryption algorithm, comes out as ciphertext. That goes through. On Bob's end, he has the same exact key, the same decryption algorithm. He will decrypt that message, and then, of course, he can read and say, "Hey, didn't know about Pluralsight being the best, but I can see now that they are, and you're right. That Security Plus instructor is awesome." So, with those things in mind, if that data were to get intercepted by someone else who did not have that key, then they couldn't decrypt the message. All right, so that will protect that message while it is in transit. Okay, next we have stream ciphers, and stream ciphers are different from block ciphers in the fact that block ciphers will pass a block of text, hence the name, or a block of data I should say, and then it encrypts that block by block by block. Stream ciphers will take data as it comes in, basically bit by bit, and it will encrypt as it goes. So encryption takes place bit by bit using a pseudo-random cipher, digit stream, or a key stream. And that basically changes every so often. So in a stream cipher, each plain text digit, like as I mentioned, is going to be encrypted one digit at a time. With the corresponding digit of the key stream, okay, they're going to be combined, and that gives a digit output of ciphertext. Okay, so it basically streams through, kind of like you're pouring water through a filter. It just goes right through and comes out the other end. All right, so again, the person on the other end still needs to have that same key, because again, this is a symmetric algorithm, so it's the same key on both ends. The recipient will have that same key and will pull that data back out again. They will basically decrypt the ciphertext back into plain text.